Okay, good morning, Year 10. I hope you all had a lovely weekend. So what we did last Thursday, we looked at volumes of spheres. So we've kind of done the volumes of the more kind of simpler shapes, so your cylinders, your spheres and your prisms. What we need to do now is do some of the kind of problem-solving questions to do with those shapes. So we're going to look at the applications exercise of volume, okay, for this lesson. So what I'd like you to do for your starter, I want you to pick a level. So pick either the red star, the 2 yellow stars or the 3 green stars. Pick your level and have a go at finding the volumes of those prisms, okay? So pause the video, have a go at those 3 questions for your starter, and the answers to these we'll go through at the end, just so you can mark them, okay? So your title for today is Volume of a Prism Applications, okay? And today's date is the 18th of May. How quickly is this month going? Then there's a recap of kind of the things that we've learned so far. So we've learned about your volume of your prism, the volume of a sphere and the surface area of a sphere, and also we've learned about the volume and surface area of a cylinder. Okay, so there are kind of the formulae that you might need to look back at for this exercise. Now, the first thing we're going to do is a quite complicated example, okay, to do with density. They love to involve volume with density and mass, the density formula. So let's just have a quick read of it. So 20 kilograms of molten metal is made into prisms. The density of the metal is 8 grams per centimetres cubed. How many prisms are made? Okay, so the first thing we've got to think about is how much what is the volume of that molten metal if it has a density of 8 grams per centimetres cubed and it's got a mass of 20 kilograms. Now hopefully some of you can remember the formula for density. If not, I'm going to write it on the screen now. Okay, so D equals mass over volume. So density is mass over volume. It's kind of similar to your speed, distance, time equation, okay? So we're given the mass and we're given the density, but we would need to find the volume. Now I want you to notice here, if I can highlight, that this is in kilograms and this is in grams. So we're going to change the 20 kilograms to be in grams, okay? So 20 kilograms, we multiply it by 1,000 to get it to be in grams. So that would be 20,000 grams. Now we can kind of substitute that all into the equation to find our volume. So 8 is going to be 20,000 divided by the volume. So if we rearrange that, so multiply both sides by V and divide both sides by 8, we would get V equals 20,000 divided by 8, which is 2,500. And let's think about the units. This is going to be the volume, so it's going to be in centimetres cubed. Okay, so your volume is 2,500 centimetres cubed of that molten metal. Now it says it makes it into these trapezoidal prisms, so that means we need to find out the volume of one of these trapezoidal prisms. Okay, so if we go down a little bit. Now hopefully you remember the formula for the volume of a trapezium, or just the area of the trapezium, then multiply by the length for the volume. So we would have V equals a half. We would have 4 add 6, so the 2 parallel sides, multiplied by the height, which is 3, and then for the volume we would multiply all of that by 12. Now once you sort that all out, you get a volume of 180 centimetres cubed. So now all we need to think about is how many don't know what I pressed there. How do I get rid of this? Oh no. Oh, there we go. Okay. How many of these fit into this, which we're going to do by division? Okay. So to find out number of prisms, we do 2,500 divided by 180. And the answer we get there is 13.88. Okay. Now, how many prisms were made? Were 14 made? No. 14 weren't made. Less than 14 were made. So here we're actually going to have to round down to 13. So 13 prisms were made, and that's your final answer there. Okay, because you can't have 0.88 of a prism. Well, you just can't have that because they want that specific size of prism. So you need that full size of prism. You can't have less than that. Okay, so that's why 13 full-size prisms were made. Okay, so that's the first one. So kind of get your head, the most important thing about this, get your head around this here. Your density equals mass over volume. Okay, that's really important that you get that. Our next example, once you've copied that down and paused it, whatever you need to do, our next example again is quite tricky. There's a lot of thinking that goes into this. So a drinks manufacturer wants a can to hold 330 millilitres of cola. The diameter of the can must be 7 centimetres. How tall does the can need to be? So what we've got here is we've got a kind of example drawing of what the can might look like. Okay, so you could draw a little drawing for yourself so we can fill in what information needs to be there. Now, in terms of volume, we actually do already know the volume. It says the can needs to hold 330 millilitres of cola. Well, in terms of capacity, 1 mil is equal to 1 centimetres cubed. So 1 millilitre is 1 centimetres cubed, therefore the volume is 330 centimetres cubed. Okay? So that makes things quite nice and easy. Now we know the diameter is 7, but the radius is therefore 3.5 centimetres, because that's what we need. We need the radius, not the diameter, for when we're talking about the volume. Now here we're given the volume, we're given the radius, but we're not given the height. So we've kind of got to work backwards from this. So our volume is 330. Then we would have pi times by 3.5 squared, and then multiplied by the height, and we don't know the height. So this would be, in terms of kind of your formula for the volume of a cylinder, V equals pi r squared h. Okay, that's where all that kind of comes from. Your V is 330, your R is 3.5 squared, and we're trying to find h this time. So what we can do to find h is we can do 330 divided by pi times 3.5 squared. So we've divided by the pi times 3.5 squared. Once you do that, you get 8.57 centimetres to 3 SF. Okay, so we found the height there just by working backwards from the volume of a cylinder. Now give the dimensions of a box that could be used. So this is all part A up here. Part B is going to be down here. Now give the dimensions of a box that could be used. Well, here is an example of a box that could be used. So they need to be packed in boxes of 12, like it says here. Okay. So we need to think about what the height of the box would be, what the length would be, and what the width would be. So the height, gone down too far. See if we can get back up to a good, there we go. The height would be 2 of the height that we've just found. So 2 times 8.57, which would be 17.1 to 3SF. Okay. Now the width, so this length here, would be 2 of the diameter. So the width would be 2 times 7, which is 14 centimetres. And then the length would be 3 of the diameter. So that would be 3 times 7, which is 21 centimetres. Okay, so that's part B. Now, what advice can you give about the use of your answers in practice? Now, would it be a good idea to use those answers that we've just found? No, probably not. We'd have to make some extra allowances, and here is why. I've kind of typed it out, otherwise it would be annoying for me to have to write. Okay, so part C, the box dimensions would actually have to be larger than what we've said because the answers have been rounded, and the thickness of the box and the cans would have to be taken account, which we have not taken into account in our answer. Okay, so there's your answer to part C down there. Now, I have selected some questions for you to do from the exercise. So it's page 309 if you're on Caboodle, questions 1, 4, 6 and 8. Okay, questions 1, 4, 6 and 8. So 4 questions there. You've got 1 density questions and then a couple of more problem-solving type of questions, okay? Once you've done those questions, please mark your work. Okay, answers are on the PDF at the back for the whole exercise. And here are your answers to your starter. So just quickly check those, please. Pause the video and check yours. Once you've done that, please take a photo of your work and send it to me. Any questions, because I know this exercise is quite hard, please just let me know if you don't understand anything, if you're not sure. Please let me know and I will do my best to help you today. All right, have a great day and I shall speak to you tomorrow.